All right, so first question we'll take a look at is evaluating an expression that has inverse trig. So this one is inverse cosine of 1/5. Okay, and they want us to do it in degrees and radians, and we're going to round to 2 decimal places. All right, so based on how my calculator is set up right now, which one of these am I ready to do first? Degrees or radians?
Radians.
Yeah, we're ready to do radians. So how do you type in the inverse cosine of 1/5? What do you press?
Second cosine 1 divided by 5.
Yep, second cosine 1 divided by 5. And if we round that to 2 decimal places, we get
1.37.
1.37. Yep. Okay, so there's our answer in radians. Now, we could convert that to degrees by hand. We do convert by hand when we're doing exact. But if we want approximate, let's just do it on the calculator. So what do I have to do to get it in? So I do it in degrees.
Hit mode.
Yep.
And then go down to where it says radians to degrees and select degree.
Yep. So it's easier to do it this way, and then just type it in again. And we get 78.46. And do you need the degree symbol on it?
Yes.
Yes. If you forget the degree symbol, it would be wrong. Okay, so 78.46 degrees. If you need to type the degree symbol, I'll make sure it's available. You just click the box and it'll pop up.
Okay.
That's how you'll type it. Okay, so any question on that one?
No.
Okay. All right, so next question we'll look at is similar. It's evaluating an inverse trig expression, but this time they want an exact answer. If we're going to be able to get an exact answer, which mode should we do it in first, degrees or radians?
Degrees.
Yes. If you're going to get a nice answer, it's going to be in degrees. So we're already in degrees. Let's do inverse tangent of root 3. Make sure when you type in the divide by 3 that it's outside the square root. And we get an answer of 30 degrees. Now, if we try to do this one in radians, on the calculator, it's going to give you a decimal that you may or may not recognize. 8.523598. Probably don't recognize. So the easiest way to get the exact answer in radians is convert this by hand. So how do we convert 30 degrees into radians?
Pi over 180.
Yep. Multiply by pi over 180. Degrees cancels. And what does that reduce to?
3 over 6. No. Yes.
So let's...
1 over 6. No.
Wait, what was the last one you said?
I don't know. 1 over 6?
1 over, yes. 30 goes into itself one time, and 30 goes into 186 times. So you get pi over 6. Now, if you can check it, we got 0.52 when we typed it in. If you do pi over 6, you get 0.52. So we know that's the exact answer.
Okay.
So any questions on how to get an exact answer in degrees or radians? Good? Good? Okay. All right, so this one says we want to find all 6 trig functions. So be careful when you read it. It's not saying to solve for theta. That's not what it wants to know. It wants to know all the trig functions of theta. Okay? So in order to find all 6, there's something we need to figure out first. Do you know what we're missing that we need to find? Yep. We need the hypotenuse. When we do this, it's going to want exact answers. So no decimals. What would this hypotenuse be as an exact answer?
The square root of 13.
Yep. This side is 3 squared is 9, 2 squared is 4. 9 plus 4 gives you 13, and then you take the square root. All right, now we're ready to write all 6 trig functions. All right, so let's start with the sign. Using our diagram, what's the sine of theta?
Two square root of 13 over 13.
So we could start out with 2 over the square root of 13, which is what I think you were going to say.
Yeah.
But then we just have to fix it. So there's our sine. What about the cosine?
3 square root of 13 over 13.
3 square root of 13 over 13. All right. And tangent? Yeah?
2 over 3.
So tangent, it's going to be 2 over 3. Okay, well, we're here. Let's just do the cotangent. What's that going to be?
3 over 2.
3 over 2. What about the cosecant?
The square root of 13 over 3.
Square root of 13 over
Oh, sorry, I was thinking 2.
2. And the secant?
Square root of 13 over 3.
Square root of 13 over 3. Now, I won't be asking you for all 6 in the same problem, but I will ask you, I'll give you a diagram. You might be missing a side, and I'll say find the tangent.
Okay.
So you just have to find one of the 6. But there'll be a couple questions like that. Okay, any questions on that?
No.
Okay. All right, let's take a look at this one. We're going to solve the triangle for everything that we're missing. So first, we're going to make a table off to the side of what we already know, and then we'll figure out what we don't know. All right, do we know A?
Yeah, it's 8.
Yep, A is 8. Do we know B?
No.
Nope, so we got to figure that out. How about C?
No.
Nope. Okay, how about alpha?
No.
No, alpha would be at the top because that's across from A, and we don't know it. How about beta?
It's 40 degrees.
Yeah, because that's across from B. All right, the order that you find the 3 things in that you're missing doesn't matter. You can do them in any order you want. Just make sure when we do the angles, they all have to add up to 180. So this is the right angle. So what would alpha have to be?
50.
Yeah, alpha would be 50. Now make sure we don't use the 50 because in case we made a mistake, it would mess up everything else. So we're going to do everything from the perspective of the 40. Okay, we need to name the 2 sides that are relative to 40. So what's the side that's labeled B?
Opposite.
That's opposite. Write that down. And the side that's labeled 8.
Adjacent.
Adjacent. And C is the hypotenuse. Okay, which side do you want to find first? B or C?
B.
Right, so find B. And what side is B?
It's the opposite.
Opposite. And what's the side that we know?
Adjacent.
Adjacent. So what trig function has opposite and adjacent?
Tangent.
Tangent. So we can set up tangent equals, and now we got to fill in the 3 things. Okay. Tangent of my
40
angle,
degrees.
40 degrees. And then what's going to go on the other side?
B over 8.
B over 8. Yep. And to get B by itself, what do we do on both sides?
Multiply by 8.
Perfect. Times 8. Times 8. And then we'll type that in, and on the test it'll tell you how many places to round to. All right, so we got 8, tangent 40. But before I hit enter, what do I want to make sure I do?
You're in degrees.
I got to make sure I'm in degrees because it was 40 degrees. Always pay attention to your mode. So that's 6.713. That's B. Okay. So now we've got 2 out of 3 of the sides. Could we do Pythagorean theorem to get the 3rd side?
Yeah.
We could. Should we?
No.
No. Why not?
Because it won't be exact and you're not sure if you're right.
Yeah. So let's just stick with what we were given, and we'll do C the same way. Let's find find C. Okay, side C is the what?
Hypotenuse.
That's hypotenuse. And the side we know.
Adjacent.
Which trig function has hypotenuse and adjacent?
Cosine.
Cosine. So cosine equals. Okay, what's my angle?
40 degrees.
Good, 40 degrees. What side is adjacent to 40?
8.
And the hypotenuse?
C.
C. And this is the one where the letter is in the bottom. So do you remember the trick we can do to get the letter by itself?
You swap the C and the cosine 40 degrees.
Yep, that's what ends up happening. And there's our answer. So just type that in. So 8 divided by cosine 40, we get 10.443. And that's C. Okay, any questions on that one?
No.
All right, so that's solving when you have a side and an angle that was given. Right, so in this one, we're going to figure out all the sides and angles again, except what they're giving us to start is 2 sides. It's going to be a little bit different. Okay, so let's go through. Do we know A?
No.
Nope, I don't have that. How about B?
Yeah.
Yeah, what's that?
3.
And C?
6.
6. Okay, and alpha we don't know, beta we also don't know. Okay. So, again, we can find each one of these in any order we want. Which one do you want to find first?
A.
A. Okay, how would you find A?
Pythagorean theorem.
Yes. And why is it okay to do it this time, but it wasn't last time?
Because those are 2 givens.
Yeah, everything's given, so it's perfect to use that. So can you set up the Pythagorean theorem to find A using the 3 and the 6?
3 squared plus b squared equals 6 squared.
3 what?
3 squared plus b squared.
Well, B is 3.
Oh, sorry. A squared.
A squared. So B squared plus A squared. And what's that going to equal?
6 squared.
6 squared. Yep. So we get A squared equals, what's 36 minus 9?
27.
27. And A is the square root of 27. Can we, it depends if they're going to ask for a decimal or not. I would say in this they're going to ask for a decimal.
Okay.
So I wouldn't worry about reducing that, even though you could.
Okay.
Let's just do the square root of 27. So 5.196. Generally in the solve problems, we do decimals. When we're writing the trig ratios, we do exact answers.
Okay.
So okay, so we've got the side. The next thing we need are the 2 angles. Okay, where's alpha?
The top corner.
Yep, it's going to be in the top because it's opposite A. All right, so that was to solve for A. Let's do, Jake, which one do you want to do next?
Let's do alpha.
Alpha.
All right.
Okay, so we're going to find alpha. That means for this part, everything is from the perspective of alpha. Okay. What position is the side that's 3 units long?
Adjacent.
That's adjacent. And the position of side A?
Opposite.
Opposite. And that's the hypotenuse. Okay, so that's our labeling from alpha. Let's see, we're finding alpha, and what are the 2 sides that we know? What position are they?
Adjacent and hypotenuse.
Adjacent and hypotenuse. Okay, what trig function?
Cosine.
Cosine. Okay. Angle? Well,
Alpha.
that's what we're trying to find. And what goes in the fraction on the other side?
3 over 6.
Yep, 3 over 6. You could reduce it, doesn't really matter. It's up to you. Okay. And now how do we get alpha by itself?
You would do the inverse cosine.
Yep, we do the inverse cosine. of everything on the left. Take the inverse cosine of what's on the right. That cancels. And now we have alpha equals the inverse cosine of 1/2. Okay, so inverse cosine of 0.5. And we get a very nice answer, 60 degrees. Do you know why we got a nice answer?
It's one of those nice triangles.
Yeah, you made the hypotenuse double one of the legs. Anytime that happens, you end up with a 30, 60, 90 right triangle. So if you had recognized that this was half of the hypotenuse, we could have known that right away. But that's fine. So it just comes out, you get a nice answer. So 60 degrees. Now we know beta should be 30, but let's just try finding it the same way. Beta. Okay. If we do everything from beta, what's going to happen to adjacent and opposite?
They're going to change.
Yeah, they're going to change. That's not true anymore. So what's B now?
Opposite.
That's now opposite. And A is adjacent. And the two sides that we know are opposite and hypotenuse. Which trig function is that? Sine. Yep. So sine. Theta is my angle. And what's opposite over hypotenuse in this case?
3/6.
Yeah, it's the same thing. 3/6. So we're going to take the inverse sine on each side. And again, we already kind of know what we're hoping for, 30, and that's exactly what we got. Okay, so beta is 30 degrees. There you go. So that's how you solve a triangle if you are given two sides to start. Any questions on that?
No.
Okay. All right, so this one is solving a trig equation. And we can do it a couple ways. We can do it the way we learned today. We can use the ASTC diagram, or we could also graph it. Let's do this one graphically. Okay, so to graph it, what would we put in y1?
1/cosine.
Yep. We're going to put 1 cosine. And Jake, what would we put in y2?
We'll put 1.3.
Y2. Oh, wait, what did you say?
1.3.
Oh, 1 point, I just said y3. Yeah, no, 1.3. Yep. Okay, so we got that. And what they're usually going to do is they're going to give you a window. They're going to tell you to find all the answers between two numbers. Let's say that I said to find all answers between 0 and 2 pi. So what does that mean I should do on the calculator?
Put it in radians.
Okay, yeah, definitely want to be in radians because they gave me 2 pi. And what about my window?
You want to make that the x min and max.
Yep, so that should be the x min and max. Okay, so take graph. And it looks like we're going to get two answers. Crosses twice. And now we just do second calc intersect. So second calc intersect. Make sure you move your cursor so it's on the part of the graph where they cross. Otherwise, I don't think it works all the time. Okay, so there's one answer. You get 0.69. And second answer, second calc, intersect, We could already figure it out if you wanted. It's just going to be 2 pi minus 1.3. That's going to be the second answer. So it's 6.28 minus 1.3. That's about 5. And the reason I know it's that is because of what we learned today. This is the reciprocal of cosine. I'm basically looking for another area where cosine, because that's the reciprocal of it, is positive. Cosine is positive in quadrant 4. Right? So when we find this other intercept, it comes out to 5.59. That's not 2 pi minus 1.3. Oh, I'm sorry, 1.3 wasn't our answer. Our answer was 0.69. It's 2 pi minus 0.69. That's what that number should be.
Okay.
So the other answer is 5.59.
Does that always work? Like taking the last number in the window given, and then taking our first answer and subtracting?
No, it depends on the quadrant you're in. So the only reason that worked is because I was dealing with secant, and secant is the reciprocal of cosine. So for the purpose of this chart, I can treat secant just like cosine. So I'm looking for a positive value, and I'm looking for cosine. Well, it's going to be positive here, and secant is also going to be positive here. Because if cosine is positive, secant is positive. Flipping something doesn't change whether it's positive or negative.
Yeah.
If this was a tangent problem, you would have, like if it said tangent x equals 1.3, you would have taken the first answer and added 3.14. You would have added pi. So
Okay,
you don't always subtract it from the window.
Okay.
Okay, so those are two answers between 0 and 2 pi.
Mr. Hager.
Yeah.
My calculator is just giving me 2 lines.
And you have it in radians, and you set your window 0 to 2 pi?
Yeah.
And did you type it in negative 10 to 10 for the y's?
Yes.
Let me take a look.
I believe I have it already.
So your window is 0 to 2 pi. That's 0.6. You have to set your x max to 2 pi. And now it should work. There you go.
Oh, there. For some reason I thought it was that. I don't know where it's going. Thank you.
Yeah. Now, what if they ask for all answers? Okay, that's only 2. This answer is going to repeat in general. How often?
Every period.
Yeah, it's going to repeat every period. So if they wanted all answers, first one is 0.69 plus, and now we need to put the period times m. What's the period of secant?
2 pi?
Yeah, they are all 2 pi except tangent and cotangent. So what do you put on the end?
2 pi times n.
Yep. And the same thing for the other one. It's just a matter if they ask for all answers or just answers in a certain window. Any questions on that?
No.
Okay. Okay, so last question we'll take a look at, which we kind of already did, is just graphing a trig function and seeing if you can basically match it up with a picture you'll have on the test. All right, so Jake, can you tell me how am I going to type in 2 cotangent 1/2 x?
I'm not really sure. Would you just type in 2 cotangent 1/2 x?
Okay, so what buttons would I press?
Oh, I'm sorry. 2. I'm not sure.
So there is no button for cotangent. So we got to type it in with a button we do have. Yep.
Could you do 2 times 1 divided by tangent?
Yep, 1 divided by, and then what do I want inside the argument?
1/2 x.
Yeah, just so I can avoid an extra set of parentheses, I'm just going to do 0.5x. That's how you type it in. Okay, that's 2 cotangent 1/2 x. All right, and let's say they want us to graph 3 cycles. Okay, first thing we have to do is figure out how long 1 cycle is, and then we'll triple it. What's the formula to find the length of a cycle for cotangent?
It's like the period divided by the one in front of cotangent.
Okay, so what's going to go in the bottom here?
2.
No, the 2 is an amplitude change. So
So
the,
1/2.
yeah, it's the 1/2.
Oh.
That causes a horizontal stretch or compression. So the 1/2 is in the bottom. But what goes in the top?
2 pi.
It's the length of the original period. What's the length of the original period for cotangent?
2.
No, not pi over 2. There were 2 periods that came up a lot when we did graphing. One of them was
Pi.
pi, and the other one was
2 pi.
2 pi. So it's one of those 2.
Pi.
It's pi. Tangent and cotangent have a length of pi. So the period is pi over b, or in this case, pi over 1/2. And now when you divide that out, what's pi divided by 1/2?
2 pi.
2 pi. Yep. Okay, so that's the length of 1 cycle. So how much would 3 cycles be?
6 pi.
6 pi. So let's set a window 0 to 6 pi. And we typed everything in. And how high and low does tangent go?
1 and -1.
That would be sine and cosine.
Oh.
Without any transformation is 1 to -1.
So infinite.
Yeah, it's all real numbers. So -10 to 10, that's fine. So if we hit graph, we should see exactly 3 cycles. And that's looking like it's going to be pretty good. So what you'll have to do now is you'll have to try to match that up with something that's on the test as a picture. Okay, any questions on that one?
No.
All right, let me just put the list of topics. So those are all the different topics that we just went through in the video.